How do you evaluate limits graphically? So first we have some basics of a graph. An open circle is not a point on the graph. For example, this point right here, this open circle, does not exist. So x on this graph, on f of x, -1, comma, +4 does not exist on this graph because that point is an open circle. But on the other hand, a closed circle, like this one right here at -1, +2, does exist on this graph. So this is a real point. This is not a point on the graph. Neither is this. Neither is this. Next we have limit of f of x as x approaches -1, for example, from the left. So when there's a negative sign up here, that means it's approaching from the left. And on the other hand, when there's a plus sign up here, that means it's approaching from the right. So this is easy to remember because the left side of the y-axis is negative. So if there's a negative, it's approaching from the negative side. And then the right side of the y-axis is positive. So when there's a positive sign right here, that means it's approaching from the positive side. And then we have limit of f of x when x is approaching -1 and there's no sign up here. That means you're approaching from both sides. So we can get I'll go over that example later. And finally we have when f of -1. So instead of f of x, we have f of -1, meaning that x equals -1. So what this would be asking us is when x equals -1, what does y equal? So first we'll go over this example of x approaching -1 from the left. So negative sign, that means approaching from the left. So we're going to start over here, because this is -1 right here. We're going to start over here and get closer and closer and closer to x equals -1, and we're going to start on the left side. So as we approach, we get closer and closer to this open circle. And even though there's not a point here, we're still getting closer and closer and closer to this open circle, which is at y equals -2. So the answer to this would be -2. You're approaching -2. Next we have x approaching -1 from the right. So as x gets closer and closer to -1, the x value gets closer and closer to -1 from the right. So we would start up here. Technically we'd start here, get closer and closer to -1, and then we'd jump up to here, and then get closer and closer to -1. And even though it's an open circle and there's no point here, we're still getting closer and closer to this open circle, which is at y equals 4. So as x approaches -1 from the right side, we're getting closer and closer to the y value of 4. Even though we're not reaching it because it doesn't exist, we're getting closer and closer to the y value of 4. And then finally next we have limit of f of x as x approaches -1. So that means we're approaching from both sides. So we start where we started before and where we started after that, and we approach, get closer, approach, get closer. But if you remember, this one was approaching the y value of -2, and this one was approaching the y value of 4. So that means these 2 points, when you approach x equals -1 from the right and x equals -1 from the left, they don't agree. They don't meet at the same y value. This one's y equals 4 and this one's y equals -2. So because they don't agree and they don't meet at the same y value, the answer would be it does not exist. And finally we have f of -1. So in this, x is equal to -1. So that means we're finding the real point, which would be the closed circle, we're finding the y value of the real point at x equals -1. So when x equals -1, the real point, the closed circle, has a y value of 2. So it's approaching 2. Okay, so next we can look at some more examples that have to do with this asymptote, this red asymptote at x equals 2. So now we have to find the limit of f of x we have to find the limit of f of x as x approaches 2, as x approaches 2 from the right, as x approaches 2 from the left, and we're also going to find f of 2. So let's start up here with x approaches 2. So because there's no sign here, we're approaching from both the right side and the left side. So if we get closer and closer to the x value of 2, which is right here, from the right side, we're going to get closer and closer and closer to negative infinity. And if we approach it from the left side, because we're doing both sides, we get closer and closer to positive infinity. And obviously negative infinity and positive infinity are not the same, therefore they don't agree, right? This isn't way down here isn't the same point as way up here. So this does not exist because the points do not agree. Next, when x is approaching 2 from the right side, from the positive side, so this is x equals 2, and we're going to start on the right side, the positive side, and get closer and closer and closer to 2. As we approach 2, we're going to get closer and closer. The y value, as x approaches 2, the y value gets closer and closer to negative infinity. So this is going to continue to go down along this asymptote for an infinite amount of time, and it's going to get closer and closer to negative infinity. And x is going to continue to get closer and closer to 2. So 2 from the right equals negative infinity. When we approach the x value of 2 from the left side, right, from the negative side, we're going to start on the negative most point of the graph and get closer and closer to the x value of 2, get closer and closer and closer to the x value of 2. And this is going up infinitely as it gets infinitely closer to this asymptote at x equals 2. That means because it's going up infinitely, it equals positive infinity. Finally, we have f of 2. So because it's f of 2 instead of f of x, that means x equals 2, right? Because we replaced the x with a 2, that means they're equal to each other if they can, be replaced. So x equals 2. So that means we go to the point on the graph, the real point on the graph, right? We'd be looking for a closed circle or a point on the graph where x equals 2. So 1, 2, this is x equals 2, but there's no point here. See, because there's an asymptote, there's no real point along this asymptote because there obviously cannot be a point on an asymptote. So when x equals 2, there's no real y value. So this also does not exist because there's no real y value for this exact x value.